So today we are going to talk about the different types of lenses and mirrors, and there are three. There is planar, which is just flat. There is concave, which curves in, and convex, which curves out. So planar lenses, these are the ones that and mirrors, these are the ones you're probably most familiar with. This is what you'll find in your bathroom, the windows of your house, things like that. Planar lenses and mirrors are flat and do nothing to the image or what you see. So what you see is what you get. It's the same size, the same shape. There is no change to the image. Concave lenses and mirrors curve in. This one in particular is a double concave, so it curves in on both sides, but you can see it kind of looks like the letter I, the capital I for curves in. So concave mirrors and lenses curve in. And the last one is convex. Convex mirrors and lenses curve out. And it sort of looks like an O. If you round it a little bit, it looks more like an O for curves out. We're going to focus on concave and convex today and what they do to the images when the light refracts through a curved lens or reflects off of a curved mirror. So for our first activity, or our only activity, we're going to be using this 4-piece graphic organizer that has the 4 different lenses and mirrors on them. I'm going to use 3 different colors to track the light rays and the way the object is going to move. So we're going to start in this top corner, and you can see that this one curves in. So this is a concave lens. So we're going to focus first at this concave lens. And concave lenses diverge light. Diverge is a fancy word that means to spread out. So let's see what this looks like. So I'm going to use, I'm really good at drawing stick people, so I'm going to use a brown colored pencil to draw a stick person. And then I'm going to use this red-orange to draw the light rays coming off of this person's head. So since this is a lens, the ray is going to go through the lens. Notice it doesn't bounce off, it goes through. This is where we're going to see some refraction occur because it's going through. And then the ray is going to bend away. So it goes through and then it bends away. And then I'm going to use a blue colored pencil to show how the light is moving off of the foot. So it goes through and it moves away. Notice they're spreading out. They're not going towards each other, they're spreading away. So it's that spreading out again. And notice it starts with S, spreading out. So the image that's created is actually a small image. We get a small image. And so we're always going to see that spreading light is always small. Spreading light is always small. So this is a concave lens, also known as a diverging lens, because it spreads out the light and creates small images. So if we know what a concave lens does, a concave mirror is going to do the opposite. So this is going to be our concave mirror, and it curves in. See, we got that curving in again? And this is a concave mirror. So if a concave lens diverges the light, a concave mirror is going to do the opposite. And we call that converging the light, which is comes together. So diverging is spreading out, converging is coming together. Okay, so I'm back to my colored pencil. My brown one is going to be a stick person. So I'm going to draw that stick guy down here. And again, I'm going to use the red-orange to show the light. So instead of bouncing away like we did with the concave lens, the concave mirror, they're going to bounce towards each other. So the light comes in, and we're reflecting. So it's going to bounce off. Sorry, there we go, bounce off. And so reflecting is bouncing off. And so it hits the surface and bounces down. And then we're going to draw the foot ray. Comes off the foot, hits the surface, and bounces off. Notice they've crossed. And this point where they meet, we call this point a focal point. So a focal point is where all the light rays converge. So for this mirror, all the light rays, if we were to even draw more rays, would all come to this point right here. So let's focus on outside of the focal point, so outside away from the mirror. Notice that the light rays are spreading. And whenever we have spreading light, we always get a small image. So again, we have spreading light. We're talking about this way. So we get spreading light, and spreading is going to be small. But also notice that our red ray is no longer on top. It has flipped, and our blue ray is no longer on the bottom. So because of that, not only is our image small, it's also upside down. So we get, I'm going to do it in brown. So we get a small and flipped or inverted image because the rays have flipped. So a small and flipped image because our rays have flipped. And that's outside of the focal point. But before the focal point, near the surface of the mirror, we're seeing that the rays are coming together. So if spreading light is small, then converging rays or rays coming together are going to get us a big image. So we're going to see a magnified and upright image with our concave mirror or converging mirror. So concave mirrors converge the light, which is opposite of a concave lens, which diverges the light. So these guys are opposites. So if you know one of them, you should know that the other is the opposite. So those are concave. Let's look at convex. So this is our convex lens. And it's going to be the opposite of a concave lens. So if a concave lens diverges the light, then my convex lens is going to converge the light. Make that active, converges light. So back to my colored pencils. So I'm going to do my stick guy. And we're going to see refraction again, so the light has to go through the lens. So the head ray is going to go through and bend down. And the foot ray is going to go through and bend up. And notice we have our focal point again. And so just like our converging mirror, see how it's very similar? We have rays coming together to a point and then spreading out. Same thing here, rays coming together to a point and then spreading out. So near the surface of the lens, before the focal point, we're going to get a magnified image. Whoops, it would help if I spell words right. Magnified and upright. And then outside of the focal point, we're going to get a small and inverted and flipped. And the reason it's small and flipped is because the rays are spreading and they have crossed or flipped. So we get that flipped image. So that is a convex lens. Get a magnified image near the surface before the focal point, and then outside the focal point you'd see a small flipped image. So this is if your eye was over here, this is what you would see. So let's look at a convex mirror. So just like the other mirror, the light's going to reflect off, but it's going to be opposite of both the convex lens and the concave mirror. So since the convex lens and the concave mirror both converge the light, this guy is going to diverge light. So I'm going to use my stick guy again. And then the light's going to come off of his head and bounce away. It's going to come off of his feet and bounce away. So we're seeing spreading light again. See how they're moving away? So we're getting that spreading light. And spreading light is always going to be a small image. So this guy's small And he's upright because the rays have not flipped. So if you can remember one of these, you should be able to figure out the rest. I like to focus on the convex lens because I think this one's the hardest. The fact that the light has to go through and then you get two different images depending on where your eye is. This one is the hardest. So learn this one and then know that the other lens is the opposite and the mirror of the same one's the opposite. And then if you know those two, you can figure out the last one. So your drawing should look like this at the end.